recording. Okay, the recording has started. Last time we finished up talking about iterators and how iterators are the little like objects that go and put their finger on each thing in a collection, and then a collection can be iterable. And if a collection is iterable, we get this fancy like for loop style, this for each. It's called an enhanced for loop. So like for each integer x in my bag, and then some method there, process on x, whatever. And then here's an example of using that loop for the string builder, for a toString, for some bag. But based on this, and this is kind of the point of the iterator, is based on looking, like if you're looking at this toString, is this a toString in an array implementation of a bag or a linked implementation of a bag? The answer is you don't know. You don't know, but that's kind of the point, because now the toString is the same. The implementation is the same if you're making use of iterators, which is awesome. Where before, if we weren't using the iterators, if you had one that was doing a for loop and indexing an array, okay, obviously that's an array implementation. If you have one that's using a while loop and checking if nodes are null, okay, that's obviously a linked implementation. But now with this iterator, you can't tell, but that's a good thing. We want these things to be consistent. The only thing that's different is how the iterator works. But as far as me using the iterator, I don't care about that. I just, give me the iterator. All right, so next topic is exceptions, which a lot of this is basically going to be review. Because you've seen them, you've thrown them, and in assignment 2 and assignment 3, you've seen an example of like making your own exceptions. So an exception is an object. In fact, it's a subtype of object. It's a subtype of throwable, which is a subtype of object. And there are two things that are throwable: errors and exceptions. Errors are usually like, okay, something really bad has happened. You don't usually come across errors. You come across exceptions. And then there are runtime exceptions and some other exceptions that we're going to get to. So the reason we like exceptions is it gives us a really great way of separating like our normal logic of our regular code. We keep it separate from like, okay, well, what happens in that rare exceptional situation? So it gives us this ability to like, just to like, okay, this is where the normal code is, and then the exception stuff is dealt with the exceptions. We don't need the exceptions. Sure, you could do it all in one, but then it gets a little clunky and hard to make sense of. So we like exceptions because it helps us separate the normal logic from the exceptional logic. And they also make it really easy to propagate exceptions up the call stack. More on the call stack a little bit, but exceptions can either get dealt with, exceptions can get propagated up. You'll see that in a second. And it allows us to differentiate between exception types and how to deal with them specifically. Okay, more on this in a bit. So in Java, there are two classes of throwable objects. Things that you throw. Errors are one of the two throwable objects. Errors are typically unrecoverable. They are very generally they're very abnormal, and you don't try to handle errors. So errors are regarded as unchecked, meaning like the point is if we're not going to deal with errors. If you see an error, just run your code again because something crazy bad happened that probably had nothing to do with you. Exceptions, on the other hand, are different. I know you've all seen exceptions before. You've got an exception. You try to index a bag or index an array out of bounds, you get an array index out of bounds exception. If you try to get something from null, you're going to get a null pointer exception. You've seen these exceptions. So we have seen multiple examples of throwing exceptions. Like here's peek from a stack, the throw no such element exception. Okay, so this no such element exception is an exception type that exists within Python. So let me go linked sorted bag, no such element exception. Here's the no such element exception class, no such element exception.java. We'll see it is a public class, no such element exception, extends runtime exception. Okay. And there's all these like weird functions in here, or methods in here. Long story short, creating your own exception is trivial. You will see examples of that in, let's go 102, data, assignment 2, resources, nope, source. Exceptions. This is an example of an exception I made for you. I gave it to you for the assignment. This is an exception that gets thrown if the maze has no endpoints, like a start or an end. There was another one in here. Location not in maze exception, right? So there's another exception. I wrote this exception. And to do this, you basically copy and paste this, and you just change the name that you want. So creating your own exception objects, your own exception types is really easy, but we don't actually typically do that because Java comes with a lot of like prepackaged exception types for us that we would use. So it's not very typical that we actually make our own exceptions. That's very rare. The only reason I did it for the assignment was more to show you like, hey, you can do this. But realistically, I shouldn't have done that. I should probably do like, in the case of, where was it? Location not in maze exception. Whenever this gets thrown, I probably could have thrown a like illegal arguments exception, which is an exception that already comes with Java. The point is you can make your own exception types, but you don't typically do that, but you could, which is neat. So this no such element exception is one that we got from Java. And if we go look at, let's go look at the array queue. At the top, I had to import no such element exception. Okay? And that's like how I got it. And if you're saying like, how am I going to remember to import that? Well, don't worry. IntelliJ is pretty smart. Because if you don't, you hit Alt Enter on it, it'll be like, just import it. So yeah, IntelliJ will take care of that for you. You've probably seen that a bunch already. So yeah, that's one of the pre-packaged exceptions we have. And then often we like to put little messages in there because when the exception gets thrown and if it's not handled, when you see the exception get thrown, like here, let me show you real quick here. If I say, Q of type T, integer, a new array queue, and then I say my queue dot first. Okay, and if I run this, we'll see the exception. It's doing its thing. What? Why is it mad? Class interface or num expected. Oh, did I not have too many? Let's try that again. All right. Exception in thread main, no such element exception. And then it prints out that message, first from an empty queue. That's what, where's first? Oh, that's array queue. There's DQ first. First from an empty queue. So this is what gets printed out. And we like these messages because it can help you just decide like what went wrong and where it went wrong. Even though it tells you right here, line 67 of this class, but still, the messages are nice. So we use the exceptions to mark an exceptional situation. Exceptional situations are not necessarily bugs or errors. It's just something peculiar that very well could be a mistake. Like for example here, this trying to get first from an empty queue is a little weird because the expectation is if I do peak or first from an empty stack, okay, or I guess it would be top. Peak? Yeah. No, peak. Okay, yeah. Peak or pop from an empty stack. Like, the expectation is if I ever do a peak or a pop, I get something back. So if it's empty, what do I do? Because the expectation is, the functionality of this method is it returns something to me. But what do I do if there's nothing to return? Do you return null? I mean, that's not an unreasonable idea, but then if the expectation is I'm getting an object back, so I'm expecting to get something that's not null back. So what I'll do is I throw an exception, because that's a weird thing. This would be a surprise scenario, and we like to write our methods with following like the principle of least surprise. So it would be a surprise if I got back null. If I see an exception, well, that's because like, oh, okay, the programmer messed up. They weren't doing their bookkeeping well enough to know that that stack was empty and they tried to pop from it. So that's something funny happening. Now, we can deal with exceptions that are thrown. Maybe this isn't necessarily that big of a deal that it happened, but more on that in a moment. We also saw other examples, though, because throwing an exception is what we're doing here with peek. But using exceptions isn't the only option. An alternative option is sentinel values, which is what we saw with that sentinel index of, where instead of throwing an exception if the element's not in the collection, return a special value that has meaning. So I could make the argument that I could write a peek that if it's empty, you just return null. And then that would be like a sentinel version of peek because, oh, it returned a special value that has some special meaning. If I get null back, it means it was empty. That is a reasonable decision. It's not that uncommon. In fact, let's go have a quick look. Java 17 Q. Add, offer, peek, and pull. Here we go. Remove and pull. Look at this. So, if we look at, so this is the Java's queue. Okay, we wrote our own queue, but Java has a queue interface that exists. There are two methods here that tries to remove something from the queue. But if we look at remove retrieves and removes the head of the queue. This method differs from pull only in that it throws an exception if the queue is empty. And then if we go look at pull, retrieves and removes the head of the queue or returns null if the queue is empty. So this pull would be the sentinel version. And remove is the not sentinel version. Remove is the one that throws the exception. So it's not even that uncommon to have both versions of those methods to be used when it would be appropriate to use them. Now, deciding when it's appropriate to use which version, that's entirely up to you as the programmer and what makes sense for what you're using it for. But be aware that there's like exceptions or like sentinel values that could be used to kind of serve a similar-ish purpose. All right, the motivation of using exception here is that if someone tries to peek at an empty stack and it's empty, what should happen? This is going to be situational. Perhaps this means some critical error happened. So the question is, what happens if someone tries to peek from an empty stack? I'm writing the stack, and someone later in the future is going to use my stack object. What happens, what should I do today if in the future they want to pop from an empty stack? What do I do? Well, I don't know what they want to do in the future, so I can't really make that decision. But what I can do is I can throw an exception, give it to them, and then based on what they get back, they can make a decision about what to do. So if an exception happens, maybe that means something critical happened and the program needs to stop executing immediately. Like that example of, and this isn't the best example, but we can use it as an example of like a medical device that is supposed to give a precise amount of radiation therapy to someone. But maybe something really weird happened in the program, and if we ever pop from an empty stack, that means our calculation has gone wrong. And the radiation dosage that I'm about to give someone is going to be off, meaning I need to stop executing immediately if this exception gets thrown. So I would say, okay, peek. If peek worked according, like normally, great. If it didn't, I deal with it by saying, stop running my program. Or maybe if this happens, it's actually not a big deal at all. Maybe I'm flying a helicopter and every once in a while I need, like, I might get a peak from an empty stack, but that doesn't really matter for the operation of the program running the helicopter. So I just ignore it if that happens. I get the exception. It's awesome that they let me know that something exceptional happened, but I just ignore it because I'm making that decision as the programmer of the helicopter that's making use of this stack or queue or whatever I'm saying I'm implementing. Because the option to immediately stop running the program isn't really appropriate if the program's keeping you in the air because it's running your helicopter. So the point is, I can't know today what you want to do in the future to address the exceptional situation that happens in your program. Should you immediately stop? Should you immediately ask for more input? Should you immediately just ignore everything? I don't know. But you know, as the person using this data structure. Okay, the message, yeah. When the program crashes due to a runtime exception, you will see the stack trace. So, the stack trace. This is the stack trace. This tells you where in the program something went wrong. And it actually starts, it'll start with the main. The main will be at the very bottom. And if we click this, it'll be like, well, on line 7 of the main, there was an issue. But of course, line 7 of the main was a method call in the myQ class. So we have to go in the myQ class because this calls the method first in the myQ class. So that goes into this method first. And then on line 67 here, this is where something funny happened. So this stack trace tells us like where in the program we are. This could be insanely large, rather short like this one where there's just like, it's just 2 things there. But this tells you where in the program the error happened. And it's kind of cool because if you're like, oh, okay, because you could imagine in my main, I have 1 million calls to first, right? And then if it just tells me, like imagine it only gave me this line and it said, oh, array queue, Java line 67 in first. I'm gonna say, well, which call to first? Well, the call to first, I can tell because this tells me. It was the call to first on line 7. Let me show you what I mean. If I say my queue.inQ 11 s out that, and then I say my queue pop, and then s out there. Pop. Oh, I guess DQ. Right. So the idea is there are 2 uses of first. If I run this, it'll say, oh yeah, okay, we've got an issue. Line 67. But if I'm just looking here, I'm gonna be like, okay, well the issue was with first, but I called it twice. I called it here and I called it here on line 7 and line 9. Which one was it? Well, it tells me. The one that was called in the calling method, the main, that was on line 9. So it's kind of cool. We're gonna learn more about the stack trace in topic, like the memory one, exceptions. Memory in the call stack. Perfect. The next section, the next topic. All right, catching an exception. So if someone is using our link stack for their code 2 years from now, I can't know what they want to do to manage peaking from an empty stack or getting the first from an empty queue. This is what I was saying here. Should they immediately stop the program? Should they just ignore the situation? What do we do? Well, this might throw an exception. Since the exception is not caught, okay, if I say stack.peak, do something with the object O, the exception is not dealt with. So because the exception is not dealt with, it propagates the exception to the calling method, right? So let me show you what I mean. In array queue, this method first can throw an exception, and it throws it to whoever called it, which was the main method right here on line 9. So it threw the exception to here. No one dealt with it in the main method, so it threw it out of the main method, which is to like nothing. There's nothing outside the main method. That's to me, the person who ran the main method. So it shows me this exception, which is what I would expect because an exception happened and I didn't deal with it. So since exception is not caught, okay, the main method propagates exception to the and the program crashes. Yes, so that's what I was just saying. If we don't deal with this exception some way, it'll crash our program because it just keeps propagating to the calling function, until there's no more calling functions. And then it just returns it to me, the person who ran main. And that's why I see this exception right here. So ignoring it's not great. So let's say I wanted my program to stop running immediately. Okay? I would wrap the code that could throw the exception in this thing called a try block. I could say, okay, try this. Okay? And then catch, and then here's where you would say catch the exception. So here, what's the exception type? I would say no, what was it called? No such element exception E. First call to first failed. Okay, and I'll do that again. I'm just gonna copy this, replace this with this. And this will be second call to first failed. So let's see what happens now. We're running this code. This first might throw an exception, but it might not. In fact, we're kind of expecting that it doesn't, because otherwise the exception wouldn't be the exceptional situation. So what we're gonna do is we're gonna call first. If first finishes running and nothing funny happens, we carry on and then continue on line 14. There's nothing there. We go to line 15 and then we DQ. Okay? But if an exception is thrown, specifically if a no such element exception is thrown, I will then run the code inside here. But like the catch block only runs if it catches the exception of this type. So obviously I've enqueued 11 here. I'm gonna get first. This is gonna run the try, but it won't run the catch because it didn't fail. There was no issue with first. There was no exception thrown. But after I DQ and I try to do first again, it absolutely will throw a no such element exception. So I can say run, and we will see 11, second call to first failed. There. Why? Well, because I tried this, we caught the exception of no such element exception, and then I did whatever was in here. If I wanted my program to stop immediately, I could say system.exit. This is a way to be like, stop running immediately. Oh, and then it wants to give it like an exit code, but put 1. Don't worry too much about this. This is just me using this as an example. No such element exception. Yes, thank you. Isn't it no such element exception? Isn't it a no such element exception object? Isn't? Well, it is an object, but it's also like, it's a subclass of object, but it's also a subclass of like throwable, which is also a subclass of exception, which is also, no, I was saying that backwards. So a no such element exception is a subclass of a runtime exception, which is a subclass of an exception, which is a subclass of a throwable, which is a subclass of object. This is what I mean. So we have a no such element exception, which is a type of runtime exception, which inherits from exception, which inherits from throwable, which inherits from object, which we get from the Java lang. So all of those object classes, well, all of the exceptions are objects. They're classes, they're objects, yes. But they will specifically extend exception. Or implement exception, what is it? Implement or extend, I can't remember. Empty collection exception. Extends runtime exception, great. Watch what happens though if I say, I'm gonna get rid of this exit just because. if I change this to a empty collection exception, first does not throw, where do we go here, Q. First throws a no such element exception. It does not throw an empty collection exception. So when I run this catch block will not catch the exception. If I run this, we'll see that it's because it didn't catch the exception, because the types didn't match, it ends up throwing the exception to me. I can fix this by maybe the first can throw multiple different types of exceptions. Well, you could actually have multiple here. You could say no such element exception. Yeah, they are the same. Oh, and it's telling me that we can combine them. This is like you can have, like, these are like else ifs. Try, catch, 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 catch. So you could actually, if the thing you're calling might throw multiple different types of exceptions, you can catch them individually and deal with them depending on what they are. E. So it's because I'm creating a okay, it's because when I catch the exception, I actually have to catch it in a variable. So I create a reference variable for an empty collection exception called E. That is a reference to the exception object that was thrown. So this is just because, like, I need to catch it somewhere. Now, I don't actually use E here, but you totally could. In fact, maybe what I should do is say E dot toString. And the toString basically retrieves the message that was put in. So this should say first from empty queue. Yeah. Okay, I'm gonna put this back to no such element exception. And yeah, we'll see that we're saying E.toString. So this is actually using I'm asking the exception object to give me the string version of itself. First from an empty queue. In fact, I didn't even need to call toString, right? Because it'll do that for me automatically. So I could just say print out E, and it'll just say, well, you got a java.util.no such element exception first from an empty queue. So you only need a reference variable when catching, not when throwing. That's correct. Because, and it's funny that you point that out, because look, new, no such element, this right here, the new, we are creating an instance of a no such element exception. But it's immediately being thrown, meaning that the reference is immediately getting thrown such that it can get caught. So this is like the left-hand side of the equation, where this is the right-hand side of the equation, right? It's kind of, so think of this as like an equals, I guess, kind of. And it gets assigned to whatever catches it, if it's a matching type. So, you're right, Jameson Houston. You only create the variable when you catch it, because when the method throws an exception, it actually creates the exception object. So that's a very good and interesting observation. Doesn't really matter. Like, this is not something you need to memorize, because the pattern is so straightforward that if you don't even think about it in terms of of like, oh, an object, whatever, like, sure, you're fine. But yeah, also, when you catch an exception, it follows the rules of inheritance. A no such element exception is a subtype of a runtime exception. So I can do runtime exception E. And watch what happens when I run this now. It'll catch the exception that was a runtime exception, but of course when we printed out E, it's saying, well, it was a no such element exception, but that's fine because a no such element exception is a runtime exception. Can you explain what the try does again? It just means, here's a chunk of code that I want you to try running, Java, but it might throw an exception. So the DQ obviously could have thrown an exception as well. But Yeah, you, the try means try this. And if you catch it, if an exception is thrown, see if you can catch it. So anything within the try will try to get caught by the catch. If you don't have a catch, it's gonna be like, yeah, you need a catch. You can't do this without a catch. Or a finally, which is a kind of like a catch. Yeah. Now, I'm gonna warn you. Yeah, it is like an if statement. Because you can, and it's like an if followed by multiple like else if, else if, else if. That just basically checks the type of the exception. Was it a runtime, no such element exception, empty collection exception, illegal arguments exception? They could be anything. You'll see also that like, IO exceptions are really popular. Remember how like, going back to the beginning of the class, remember how it was kind of a pain in the ass to do file IO because there was always all these different exceptions that can get thrown? Well, more on that in a moment. Yes, so it's because IO exceptions, and there's a lot of different types of IO exceptions. Like, oh, was it having an issue parsing it? Could it file not found exception? There's a lot of different types of IO exceptions that you might have to manage, because if you try to open a file and then read from it, and you catch an exception, well, which type of exception was it? Because I'm gonna wanna react to the situation very differently if the exception is I couldn't find the file versus the file has a wrong format. Okay, okay, catching exceptions. Okay, yeah, stopping immediately, carry on, whatever. Oh yeah, and then there's print stack trace. Yes, yes. You can say e.print stack trace. This is an even more handy version of than printing out E, because it shows you the whole stack trace. And then there's rethrow. So perhaps we want to catch the exception and then just rethrow it as something more appropriate for some context, right? So let's say I'm doing like, oh, okay, peek, and then do something. But if I catch an exception, you know what? I'm not gonna deal with this here. I'm just gonna propagate this exception to whoever called me so they have to deal with it. And this is entirely doable. This is just propagating the exception up that like, okay, I'm not gonna deal with it, someone else is. And there's an example of this I think we see later in the course. And in general, if it is possible the code trying to throw multiple types exceptions, yeah, you could sub exception A, B, C. And then there's this finally block that always runs. So it's like, it's kind of like a, okay, if you need any cleanup code, you don't typically need these very often, especially at this stage. Okay, if you have multiple catch statements, we must be mindful though of the class hierarchy. For example, file not found exception is a subtype of an IO exception, which is a subtype of a runtime exception. All file not found exceptions are file IO exceptions. So if I catch a file IO exception, sorry, if this try throws a file not found exception, this catch block will deal with it because a file not found exception is an IO exception. And when a catch block runs, it's like an else if. Only one of the catches will run. So we have to be mindful of the order we put these in. Because if, let me see if I can show you. I have a feeling IntelliJ will even warn me. Try, S out, catch. If I say IO exception E, followed by a, just print out E. Why is it whining? Not imported? Is never thrown in the corresponding block. Just, crap. This is probably gonna ruin my example. Catch, file not found exception, E. Okay, yes, so it's saying, IntelliJ is smart enough to say, hey, a file not found exception will already be caught because IO exception would catch it. So in order to solve this, you just change the order. Always have the most specific exception type first and then get more general as you go down. That's all. Again, this is a peculiar scenario that you're not really going to need to think about a lot in this course, if at all, following this topic. I just want you to be aware of it, so if you need it in the future, you'll think like, yeah, I remember seeing something about that, and you'll know what to go look up. Yeah, okay. Since file not found exception is a subclass of IO exception, if a file not found exception is thrown, the first catch statement will catch it. In this scenario, it would not be possible to run the code within the second catch statement because all file IO exceptions are IO exceptions. Our file not found exceptions are IO exceptions. This is easily fixed by switching the order, and then we have finally. There is another special keyword finally that comes up in dealing with exceptions. The code within the finally block will always run regardless of if an exception was thrown or which exception was caught. This comes in handy if we have any code that needs to run no matter what, like closing files that may be left open or something, because, yeah. I have an aside on creating your own exception. There you go. Existing throwable except, yes. And I just kind of describe it. Now, there are things called caught, are checked and unchecked exceptions. And I'm probably going to get this wrong, but the spirit of what I'm about to say is what's important. Some exceptions, so you will notice that, you know, I didn't have, here, let's go back to here for a second. Here we go. Buffered reader. Okay. If I say, I'm going to copy this right here. Okay. Are you going to leave the website up for the foreseeable? Oh, it'll be up indefinitely. I mean, it might get altered over the years slightly as they make tweaks and whatnot, but the content will be there. Okay, so if I paste this, crap, yeah, it's gonna be mad about this. Delete. And what's that thing? Control K or Control? No. What's the hotkey to fix the? Oh. All right. Well, it did it. Control Alt L. Well, whatever. We're good. So I'm gonna import these things. Import. Okay. Great. Now if I say reader dot read line. Okay. If I write this, Java's mad at me. It's saying unhandled exception. Java io.io exception. If I click this, okay, I'm gonna click read lines. Where is that gonna throw the exception? Throws IO exception. Ensure open. Okay, perfect. If I click ensure open, here we go. So read line calls a method called like read line, which calls a method ensure open. And we will see here that that means this IO exception could be thrown, stream closed. There are a lot of different things that could happen. So there's ensure open. Let's go back to where that was. No. Okay. So this, okay, read ensure open. Okay, I'm not going to look any deeper just because we're running out of time. But the point here is this might throw an exception. But Java won't let me run this because it's saying unreported exception, Java IO exception must be caught or declared to be thrown. Why is this not letting me run my code when my first throws an exception, but I didn't actually have to write the try around it? Like, it would still run if I didn't put the try around it. Like, let me show you, right? If I do this and I say my queue first, I could write this a bajillion times and Java's not going to care. despite the fact that first is throwing an exception. But read line, it's angry. Read line is saying, yeah, you have to deal with me. And there's one key fundamental difference here. It's because this is a checked exception. I think this is the right word. I might be misusing my words. These are a special type of exception. Some exceptions, if they're thrown, whatever, doesn't matter, right? If someone catches them and deals with them, great. If not, whatever, they get thrown to the user. An example of this would be like first here, or null pointer exception, right? Every time I would say like first, and then I would say like dot, first dot, toString, right? So first would give me back an integer, presumably, and then I want to call toString on it. Great. But the issue is, what if first, like, this is a bad example because first can't return null. If I have a method that's like get data from a node, and I say, okay, get data dot equals, well, that might be a null pointer exception. I didn't need to try to do something and then have to catch a null pointer exception. I didn't need to try to index my array and then catch a potential array index out of bounds. A lot of the exceptions that can get thrown are those that are like, if this happens, you did something wrong. You don't want to catch array index out of bounds exceptions. You don't catch null pointer exceptions because they happen because something went wrong. But they want to make sure you deal with this IO exception. So the way they do that is look at this function definition. Public string read line throws IO exception. Then we have the open brace. By putting the throws in here, it's now going to require that we check it. And I'm pretty sure I can give you an example of this right now. Hopefully this goes the way I'm looking for. Throws, no such element exception. But now if I go here, oh, maybe it's not mad. My queue, array queue, why are you not mad? I guess because it's a runtime exception and it's not a catch to caught exception, so that actually won't work. Well, okay, fine. The exception type that I inherited from is not going to make it work the way I was hoping it would, but that's okay. The point is, there are types of exceptions that require the programmer to deal with it. This would be like if you're writing code where it's like, they better effing deal with the exceptional situation that happens. Array index out of bounds, the programmer messed up, they'll figure it out. File IO exception, something bad happened, they have to tell me what to do if this happens because I can't deal with it. How would you fix that? How would I fix what? Making mine throwable? One, or make mine be like the method throws the exception? I probably wouldn't in this scenario, but the way to do it would be to make it like a subclass of a method that, or of an exception that is a checked exception. Oh, the read line being underlined. Wrap it in a try. Try. And then catch. IO exception. E. SO. E. There. There. Now it shuts up. Because I said, okay, try. And because it's in a try, it knows that, okay, we're going to look to catch something. An alternative way to deal with this, and the alternative way I'm about to show you is not recommended, is just to go up to your main and say throws IO exception. And that'll shut it up. Because what that says is, oh, don't worry, read line. The method main is going to throw it, and then the calling method is going to deal with this. There is no calling method because this is the main, meaning this is just going to throw the IO exception at the user who ran the program. So don't do that. But it's an easy way to make it shut up if you just need it to work. Otherwise, put this in a try catch. That's all. So that's, yeah, that's about it for exceptions. Yeah. Yeah, there we go. Runtime exceptions, other, yeah. Cool. That's about it. And yeah, we are out of time. Next time, we'll start talking a little bit how Java memory works, which is fun. And then we get to recursion, which is even more fun. All right. Any last questions before we wrap up for the weekend? All right. Well, either way, I'm going to stop the recording.